Course 2, Lesson 6, we are going to be looking at two ideas today, factors and divisibility. Divisibility, we're going to see at the end of the chapter, end of the lesson today, and I'm going to have you turn there right away and look at page 42 because I'm not going to really talk about this other than show you this big box, and it says test for divisibility. And there are 9 different, well, 1, 2, 3, 4, 5, 6, 7, 8. I guess there are 10 or 12 different things of how you know something can be divided. So I'm not going to look at that necessarily except for a couple of examples. But I want you to know that this is there. Page 42 is a big reference for you when it comes to this. But I'm going to focus more on factors. What is a factor? All right, factors do mean that we have to use division in order to find it. So let's go to the definition of a factor. Okay, on page 40 it says a factor, the factor of a number are the whole numbers that divide the number without a remainder. So let's take the number 12 for a second. Okay, 1 and 12, we can do 1 divided into 12 and we can get 12. No remainder. We could do 2 and 6. And if we did that, we could definitely come up with 12 because 12 divided by 2 is 6 and 6 divided into 12 is 2. So again, no remainders on any of these, so these both work. And then we have one more. We have 3 and 4. So 3, wow, that was a bad 3, divided into 12 is 4, and 4 divided into 12 is 3. No remainder. So this group right here all equal 12. And we could set it up like this. We could do in order 1, 2, 3, 4, 6, 12. And we could draw these lines 1 to 12, 2 to 6, 3 to 4, because each of those equal 12. Okay, so let's do a harder one. List the factors of 51. Now 51 looks like it's prime, like you can't divide anything by it. But we know that 51, because 5 plus 1 is 6, we know that it's divisible by 3. So 1 and 51, 3 and what? Well, what goes into 51? So we have to do this problem. Oops, that should be a 3. Oh, it's 17. So here are the factors of 51. So it's 1 and 51 and 3 and 17. A little dyslexic this morning. Okay, so that's how you find the factors. So the factors would be listed as 1, 3, 17, and 51. Those would be factors. All right, not too difficult. Let's look at example 3, and now we're going to be introduced to another concept. It's called greatest common factor. All right, so what is the greatest common factor? And we're going to be looking of two numbers. We're going to be looking at 18 and of 30. Okay, I always start like this. If I have 18, and 18 is, let me redo this. And I'm going to make a factor tree. Because it's even, I'm going to divide it by 2. What's 2 divided into 18? It's 9. Let's divide by 3. 3 divided into 9 is 3. In other words, 2 times 3 times 3 equals 18. Okay? So, let's do the same thing for 30. Because it's even, let's divide by 2. We know that's 15. We know we can divide it by 3 and get 5, and we can't go any closer. So 30 is equal to, in order, 2 times 3 times 5. Well, we know that these two are the same and these two are the same, but these two are a little bit different because we don't have the same. So what we're going to do is we're going to say 3 over 5 is the lowest common factor, or common factor that is part of that. There's another way to do it that your text gives. Okay, greatest common factor, and again we're going to do 18, and we're going to say 1 times 18, 2 times 9, because this is what we did when we factored it, right? 18 we said 2, we said 9, and then 3 and 3, right? So is there anything other than these things that we can get 18? Well, yeah, we can get 3 and we can have 6. So 18 is 1, 2, 3, 6, 9, and 18. See where this comes into play a little bit? Okay, just helps. Oh. Don't know why that just did that. Okay, so this helps, right? This part helps. Okay, so let's do 30. Okay, we did 2 and we found out 15, and we did 5 and 3. So this is going to help us. So we know that 1 times 15. We know that there's 2 times, or excuse me, 1 times 30. Sheesh. 2 times 15. But is there anything else that helps us achieve 30? Yeah, there is going to be 3 times 10. There is going to be 5 times 6, or 6 times 5, same thing. So we have quite a few factors over here. So for 30, we're going to say 1, 2, 3, 5, 6, 10, 15, and 30. So these are the same, these are the same, these are the same. 6 is the same, and then nothing else matches, because this is 18, this is 15, this is 30. So we're going to say that the greatest common factor, they both have it, is going to be 6. Okay, so that's how you find the greatest common factor. We're also going to do a lesson that calls the least common multiple, which uses this more. But greatest common factor, you have to do all of these all the way out in order to find that number. Okay? All right, next is the divisibility test. And I'm just going to have you read through those on page 42, like I mentioned before. And it's for the division of numbers of 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so all of these numbers, if you can figure out the division test for all of these numbers, then every other number works. So, for instance, if we pick the number 8, look at rule number 1. If it's 2, right? If the last digit is even, well, is this even? Yes. Then we can divide it by something. In fact, we can divide it by 2. All right. If the last 2 digits can be divided by 4, well, what does that mean? Okay. What if we have a number 328? If 28 can be divided by 4, which is possible, then we know that we can divide this by 4. So it's rules like that. You're just looking at all these different rules, and again, you don't have to memorize them, but page 42 is going to be a great resource for you to go back and answer those kinds of questions. Other than that, that's your lesson today. So if you have any questions, go ahead and talk with me, and I'll be willing to help you.